This wasn't planned at all. A while ago I had a failed print, literally just a single layer of PETG. Normally that's something I would just throw away, but this time I picked it up and immediately it felt different. Not like a normal 3D print. It was thin but way stiffer than I expected, while still being flexible. Almost like a thick plastic foil. So I started bending it a bit just out of curiosity, and instead of cracking or snapping, it actually held its shape. That's when I stopped and thought, wait a second, what if a 3D print isn't really finished when it comes off the printer? What if printing is just the first step and shaping comes after? After that moment, I started thinking a bit more seriously about it, because normally, when we design something for 3D printing, we treat the print as the final object. If we want a curve, we model a curve. If we want a hinge, we design a hinge. Once the print is done, the shape is fixed. There's usually no step after that, and suddenly that felt surprisingly limiting. Of course, this idea depends a lot on the material. Not every plastic behaves the same way when you try to bend it. PLA, for example, was an immediate no. It's too stiff, too brittle, and it really doesn't like being flexed at all. So I started focusing on materials that are known to handle stress a bit better. PETG was the first obvious candidate, TPU was another option, and ideally something like polypropylene if I can get that to print reliably. The goal was pretty simple. I needed something that's thin enough to fold, flexible enough to survive daily use, but still strong enough to actually be useful. The first tests were honestly not that great. Folding plastic like paper just doesn't really work. The material resists the fold and constantly tries to return to its original shape. That causes the folds to stack up, which very quickly makes everything thicker and clumsier than I wanted. So instead of forcing the material, I tried something else. I started heating the print before folding it. And that changed the behavior completely. The plastic relaxed, the folds became cleaner and thinner, and most importantly, they stayed in place. For the first time, it felt like I was actually in control of the shape. To make this process more consistent, I took it one step further and designed the flat print with subtle fold lines already built in. They don't weaken the part, but they guide the material exactly where it's supposed to bend. That small detail made the entire process much more predictable and repeatable. Once this started working reliably, I wanted to turn the idea into something practical. Something that actually benefits from being folded instead of printed as a solid object. That's when I landed on the idea of an origami-style wallet. A wallet that starts out completely flat and only becomes usable after you shape it. No hinges, no screws, no moving parts, just folds. With everything I had learned up to that point and after hours of refining the 3D model with the fold guides already built in, I finally got to work. I started testing different materials, trying to fold them into a wallet that actually works in everyday use. While folding the different materials, a few things became very clear. PETG is actually very easy to work with and responds really well to heat forming. At the same time, it's still quite stiff, and for a wallet that means it doesn't feel quite as comfortable in the hand as I would like. ASA behaves similarly. It can be shaped nicely, but it also tends to crack if the layer bonding or the fold lines aren't dialed in perfectly, which makes it a bit less forgiving. Polypropylene, on the other hand, works extremely well. It feels high quality, flexible and very durable. You do have to be careful when heat forming it though, because it can get sticky quite quickly if it's overheated. TPU was probably the trickiest to work with. It doesn't like holding its shape as easily during forming, but once it's folded, it gives the most premium and long-lasting impression out of all the materials. In the end, the wallet can technically be made from all of these plastics, but TPU and polypropylene definitely stood out as my favorites. The final result is intentionally very simple. It holds cards and cash securely, stays extremely slim, and feels more like a formed object than a typical 3D print. But there was still one important question left, and that was durability. A wallet gets opened and closed at the same spot every single day. So if this idea was going to make any sense at all, it had to survive repeated stress. If you assume a lifespan of around 3 years and opening it once or twice a day, that adds up to well over 1,000 folds. So that's exactly what I tested. And honestly, it held up much better than I expected. This project completely changed how I think about 3D printing. Not as a way to create finished objects, but as a way to create material that you can shape afterwards. And I think that approach has a lot more potential than just this one wallet. If you want to try this yourself, the flat print file and a detailed folding guide are available on my Ko-fi. Thanks for watching.